So actually it's my pleasure, and I'm quite excited about the symposium about evolution of musicality. So yeah, that's it, I think, actually.
Well, so good morning. I was asked to chair this next symposium, so on the evolution of human musicality. And the first speaker will be Marco Varella from University of São Paulo, which will present, as you can see, his talk on nocturnal selective pressures on the evolution of human musicality.
Thank you, Professor Edu. Good morning, everybody. It's an honor to be here. I'm glad to see everybody here. So, in my talk, I will explore the temporal dimension and how it can illuminate some points about the evolution of human musicality. I'm Marco Varella. I'm a postdoc here at the Institute of Psychology, Experimental Psychology department. And, well, if we take a look at the literature, and the literature is really scattered, right? We can put together many different evidence that combined as a whole indicates that human musicality might be an evolutionary adaptation, right? So, because it fits many criteria commonly believed that indicates adaptations. It's very old. If you think about the voice, right, the ability to sing or to speak, the anatomy of the voice is already ready long ago, 2 million years ago. And most recently we start finding musical instruments. It's universal, right? So all cultures have music. It evokes strong emotions and pleasures. And it's very costful, right? So in terms of time, energy, effort, and it's really very different between humans and our very close relatives, right? So humans are better at doing music than artificial intelligence, for instance, and our closest relatives, apes. And of course, there are many predispositions, right? So it's very fun to learn music, to sing, and I could observe firsthand in my own children that they, before speaking, they were already singing, right? And if you look to the animal literature, the comparative literature, you can see that many species, they have capacities to do long, elaborated songs. And so everything together gives us a strong confidence that musicality might be an adapted feature of human nature. Now, I said that humans are very different from our closest relatives, but if we look closely, we can see that they have already many precursors of musicality, right? So musicality didn't come out of nowhere, right? There are already some level of proto-musicality in chimpanzees. There are studies showing that they have capacities for rhythmic synchronization and entrainment. They can get into a rhythm. Tendencies for drumming, for instance. They prefer more consonant music. They prefer human African and Indian traditional music over silence, right? And of course, in nature, they have many classes of behaviors that we could say that there has some musical side to it, like rain dancing and pant-hoot chorusing and their carnival displays. Lots of vocalizations, grouped together. And there was one study that showed that in captive chimpanzees, instrumental music increases affiliative behavior, while vocal music decreases agonistic behavior. So, of course, very few studies, but they can already give us a sense that there was, in the common ancestors of humans and chimpanzees and bonobos, there was a level of musicality, some proto-musicality. Now the question is how this common ancestral proto-musicality became the full-blown human musicality, right? So we'll be focusing in this initial part of the history, right? Well, Charles Darwin, despite saying that music is one of the most mysterious traits that humans possess, he suggested, after going through many types of evidence, right, he suggests that maybe sexual selection could be part of the answer, right? And last year we celebrated 150 years of this Darwinian suggestion. And so he argued that the pleasures, the universality, the prehistoric antiquity, emotions evoked, and the adaptive conversions of musical and dancing behaviors become intelligible to a certain extent if we may assume that musical tones and rhythm were used by our half-human ancestors during the season of courtship, when all animals of all kinds are excited not only by love, but by the strong passions of jealousy, rivalry, and triumph. And since Darwin, of course, the field, and especially in most recent decades, the field has really expanded, the evolutionary musicology, biomusicology field. And so many theories for the ancestral adaptive value for human musicality have been proposed, from individual to kinship advantages, from pre-puberty to post-puberty selection focus, from indirect effects on fitness to direct effect on fitness, on non-artistic domains, right, related to fitness. So, for instance, the music could help you to be more creative in general, and then you can use these to solve your survival problems, so some indirect effects. From survival to reproductive benefits, and from intersexual to intersexual selection. So nice variety of possibilities, and I have just put together a few here. So musicality might have promoted ancestral social cohesion and coordination, signaling of coalitions, territorial defense, anti-predatorial defense, a safe passage of time, parental care, like the mother-infant bonding, all the lullabies, mate choice, and mate competition. It's important to stress that the theories per se are not necessarily mutually exclusive, right? So what we need is really more data. In 2005, Steven Pinker, he's very critical to adaptive theories of human musicality. He has proposed that music only reuses the cognitive machinery for language and acoustic evaluation, right? And in 2005, in a preface of a book, he argued that the proposed adaptive functions of musicality, such as group cohesion, they are circular, thus not proper explanations. because they do not rely on a set of principles independent of the part of psychology being explained. So he gives there an example of the human eye, right? For you to explain the adaptive value, to do the reverse engineering of human eye, you have to go to optics and how light behaves, and then you can understand why the human eye has such a configuration of parts promoting sight, right? So he said, generating and sensing sequence of sounds is not an independently motivated solution to the problem of maintaining solidarity in case of group cohesion, right? In the way that, say, the emotion of empathy or the motive to punish free riders is part of such solutions, right? So he's trying to think, okay, so if that was true, group cohesion, why the hell some sounds would make people get together, right? So, and of course, when Darwin said that music is one of the most mysterious of capacities, he was thinking about daily habits of life. Daily, right? So, what I'm doing here, I will propose to clarify the evolution of human musicality by stressing the when of how the ancestral proto-musicality evolved into full human musicality. So, I'm suggesting that the nights might be the missing piece of a puzzle that can help organize different theories in a bigger scheme. First, we have to think about my proposal is that the expansion of evening activities tied to habitual use of fire throughout human evolution might help explain how the ancestral proto-musicality became human musicality and might help to integrate current evolutionary explanations for the ancestral adaptive values of musicality, right? So, we all have this chronobiology, we all have tendencies to behave during the day, during the night, and if you go for the literature, you discover that the common ancestor of all primates were nocturnal, and apes, they are not really diurnal animals. We are more called catameral, which is like when we have activity not really restricted to a particular time of day and night. There are night behaviors in other apes, right? So, for instance, carnival displays in chimpanzees may happen during the night, and also play behavior has been observed during the night in chimpanzees. And captive male orangutans, they perform premeditated nocturnal long calls, right? So primate lineage, they really rapidly adapt to the circadian pattern, occupying either the diurnal or nocturnal niches, right? And humans, it seems that humans expanded this initial nocturnal tendency that the common ancestors might have, right? If we look to the pattern of sleep that humans have, we have a shorter sleep, which is deeper and with more occasions of rapid eye movements sleep, right? So it's like a more optimized sleeping, which gives us more free time for social activities even during the night, right? And what is a major difference between our evolution and the other apes is that we had the use of fire, right? And the fire was a significant evolutionary factor in our evolution. It started opportunistically 1.6 million years ago, and the habitual use of fire was some 400 to 300,000 years ago, right? So, and it's slightly later in modern humans. It started first, the habitual use started first on Neanderthals, right? So it was like opportunistic music, and this is wildfire, natural fire, opportunistic first, and then some transition phase, and the most recent habitual use of fire. And if we look to the tribal societies nowadays, we see that around the campfire during the nights, we have lots of eating, singing, dancing, storytelling, and rituals, right? So we can see in many places there are common rituals around the fire at night. And this is a nice anthropological study that showed that during the night people talk about stories much more than any other topic, and during the day they talk about other things, economic things, right? They joke, right? But during the night it's mostly stories, and you can see here the activities, and you see that during the nights and the day marriages happen roughly the same frequency. And the shadow exchange is when you exchange gifts and presents, like non-food items. So it happened almost the same frequency. But the trance healing, the dance to heal, then it's more frequent during the night. So we had during the night more of these activities, right? So, but what are the recurrent features of the nights that our ancestors faced every day for millions of years, right? During the night, there is low luminosity, and it impairs vision, right? So it selects for higher acoustic capacities, right? So 2020, these two authors published this very nice paper comparing 1,800 species, and they showed that the origins of acoustic communication in vertebrates is related to nocturnal activity, right? So it's a very recent finding that has important implications for theories of evolution of language and evolution of music, right? So the simple fact that it's darker, it's already would lead to a higher musicality. And then there is the dangerousness of the night, right? So then it would select for a higher alertness toward harmful agents, conspicuous preventive defense, so you make noise for the animals to be scared. It would promote, make sense to have social agglomeration, right? Because when everybody's together, we are more protected. Risk-take, sensation seeking, openness to experience, right? Curiosity during the night, and of course, anxiety alleviation, because it's, of course, dangerous during the night, right? There are many, in natural settings, there are still attacks from big cats, for instance, lions, and stuff. And it's funny because evening-oriented individuals, those that they prefer to sleep late and wake up late, they tend to be more risk takers, and they tend to be more open to experience, and they tend to be more original, open to culture, novelties, curious, and well-informed, right? And the evening's chronotype is common among musicians and composers, right? And it's common among individuals with higher beat synchronization. And in a nice study, they put like speakers in the forest, and they realized that human voices scare big predators, right? Large carnivores. Another feature of the night is that it's the period of the day that we are most tired, right? So it's more difficult for you to self-regulate, right? And we easily succumb to immediate pleasures. So people who are quitting smoke, for instance, they have more trouble not smoking during the night than during the day. evening-oriented individuals, they have lower self-control, they are more impulsive, and they are more hedonistically oriented, right? So, and we know, of course, that musical activities, they give pleasure, right? They stimulate the pleasure centers in our brain. And the last feature, recurrent feature of the night that I want to stress here is that darkness partially conceals one's identity, right? So as soon as you are a little bit farther from the fire, it's difficult to know your identity, right? So what it gives us is that this gives us a sense of privacy, anonymity, which disinhibits socially repressed behaviors, right? And we know that humans exhibit a covert courtship, hidden sexual intercourse, and when you go for the literature, you realize that humans actually have a major peak of sexual activity during the night, around 21 hours, right? And of course, most promiscuous individuals, they are more nocturnal. And if you go for the literature on nightclubs, you can see that they are really the mating grounds for humans, right? So this study is very nice. They saw that there is a 50% increase of couples leaving the nightclubs than the ones entering it. So you go there alone and end up going home with someone, right? So this increased nocturnal sexuality led to a formation of something that we might call an evening lack, right? Where more opportunities for reproductive behaviors happen, right? And it's funny because when you look for the literature on influences of sexual selection on nocturnal behavior, you see that post-pubertal adolescents are the ones more, of course, mating-oriented, right? And they are also the most nocturnal humans, right? It peaks around 19 years old. And there is a sex difference. Men are normally more nocturnal than women, but this difference is only before 4 years old. So when women start entering menopause, the chronotype sex difference disappears. And in a recent study of ours, we discovered that musical women, they have higher short-term mate value and higher intrasexual competitiveness, and musical men have higher intrasexual competitiveness, right? In a previous study, we showed that men with higher pitched singing, they are more promiscuous, right? So there are relationships between sexual life and musical life, right? And what is interesting is that there is assortative mating, right? So promiscuous people tend to get together with more promiscuous people. People tend to mate with people in the same vocational interest and the same chronotype, right? Nocturnal people, they tend to be mate with nocturnal people, right? And couples matching chronotype, they are more sexually satisfied. And so this mechanism, assortative mating, leads to trait covariation, right? To the point that this year there was one paper showing that indeed there is a genetic correlation among evening's chronotype and a more accurate musical beat synchronization and exposure to loud music, right? This one from this year, they really found a genetic connection between rhythmicity and nocturnal chronotype, right? So, in conclusion, alongside with the habitual use of fire, the expansion of human nocturnal niche exposed our ancestors to new recurrent challenges and opportunities, right? So, independent features of the night, low luminosity, dangerousness, peak tiredness, and concealment of identity might have selected for evening-oriented individuals to be more prone to acoustic communication, more alert and imaginative, more gregarious, more risk-seeking and novelty-seeking, more prone to anxiety modulation, right? And we know that music diminishes our anxiety. So it makes sense for you to, in a dangerous situation during the night, to listen to music. And more hedonistic oriented, and of course more promiscuous and disinhibited, right? So as a chain reaction, those selected inclinations might have converged and favored many proposed ancestral adaptive values of human musicality, right? Social cohesion, coordination, signaling of coalitions, territorial defense, anti-predatorial defense, safe passage of time, children lullabies, and of course sexual selection. So enhancing the ancestral process of musicality into the human-like musicality. So I conclude, and with this I try to give an answer to the Pinker challenge, that maybe these 4 nighttime features they are really the independent principles necessary for us to understand a considerable part, actually, of the evolution of human musicality, connecting many different theories. So, thank you so much.
I think we have time for questions.
We can leave questions for the end of the session to all the speakers. Okay? Okay. Who is next?
So our next speaker is Edward Hagen, which is from Washington State University. And he's going to present the talk, The Biological Roots of Music and Dance.
Okay. As I talked about yesterday, to identify evolved biological functions, we need to identify good design, good engineering. For example, the eye, as Marco just mentioned, is a well-designed optical mechanism. So we need to show that an evolved biological trait is an effective solution to an important reproductive problem. So in this talk, I'm going to emphasize comparative evidence, as Marco just did. That is looking for traits in many, many different species that share a number of commonalities, and that might give us clues as to the origins of those features. For example, eyes are very widespread in nature. They've evolved multiple times, and that really helps us understand their evolutionary history. So what are the biological roots? Now, I'm going to not really talk about the evolution of music per se, although I'll get to that at the end a little bit, but more, as Marco mentioned, what sorts of preconditions or features might be the roots of human music, the biological roots. So what do we need to explain when we explain the evolution of music? Well, it's auditory, vocal and instrumental. It's often loud. It's both an individual behavior and a group behavior, and the group behavior is the one that's been trickier to deal with. It's often synchronized. Why is it synchronized? And it has a lot of variation. What's the function of all that variation in music? It's learned. Practice in human music is typically very, very important. And it's produced by both sexes and all age groups. And the audiences also are both sexes and all age groups. And we always make quality judgments. That's good music, that's bad music. So these are the things that a complete explanation or evolutionary explanation of music needs to account for. So there are a number of signaling hypotheses. So what do we mean by signals? There's got to be some relationship between the properties of the signal and the content. Why is this signal a good signal of whatever it happens to be signaling? And the other thing that we really need to understand in the evolution of signaling is what makes the signal credible? Why should listeners or receivers believe this signal? There are all kinds of incentives to send deceptive signals, especially in a mating context. So what prevents the signal from being faked? So as Marco mentioned, the sexual selection hypothesis is one of the oldest. It's from Darwin. That singing signals mate quality. This shows good design and credibility to produce high quality music. A lot of parts of your body and your brain have to function properly, and that would be very important in a mating context. It's very widespread in nature, and it has a lot of face validity. When we think about human music, we often see rock stars and music stars being very successful in mating efforts and very attractive to the opposite sex. So I think it's a very strong hypothesis, but there's a lot of features of human music that don't seem to be easily accounted for by the sexual selection hypothesis. So for example, heterosexual adults often revere the music of same-sex musicians. That's not what we would expect from a sexual selection hypothesis. Men should not really be really enjoying the music of other men, and women the music of other women, and yet we see that all the time. We shouldn't see parents singing to their children and engaging in a lot of singing behavior in a mating if it's purely a sexually selected signal. That doesn't make a lot of sense either. Music is often used in many contexts that have nothing to do with mating, or at least nothing directly. Warfare, politics, funerals. And the emotions that are engendered by music often have nothing to do with sex or mating. So at a funeral, the music is sad. Nobody's feeling sexual in that context. And highly synchronized music is often performed by same-sex groups. So if men are competing for access to mates, they shouldn't be working together to produce music. They should be competing with each other. Again, some of these things just don't easily fit in a sexual selection hypothesis, even though obviously some aspects of music really do. Now, the social bonding hypothesis is one of the most popular right now. I'm pretty skeptical of it because I just don't think music is well designed. It's kind of what Marco said earlier. Why does a sequence of notes, why would that be a good design for enhancing group cooperativeness? What really enhances group cooperativeness is some common goal. We need to protect ourselves from a danger. We need to accomplish some goal together. That's what really promotes cooperation, not running around and producing loud sounds. So I just don't think music and dance are well designed for social bonding. For example, is Steven Tyler, is he a good hunter? Whatever his political goals, who knows? His music really doesn't tell us anything about that. So what I'm going to propose is a neglected area of animal signaling really shares a lot of features that we need to explain with music, and that is territorial signaling rather than sexual signaling. So what are some key facts about territoriality? Well, it's very widespread across species. It's not universal by any means, but it is very common in many, many different taxonomic groups. And in many of these groups, most of them perhaps, territorial disputes are usually decided without a fight. There's what's known as a prior residence effect. The owner often wins. And this is viewed as a convention. There's a big cost to fighting. Both parties have an interest in avoiding fighting. And so it's actually one of the earliest examples of evolutionary game theory, that a convention can evolve, that whoever's in the territory first gets the territory. And if that's true, it then pays to signal ownership. And so we see territorial advertisements in many, many species. So wolf howls, howler monkeys, birds. Often when you go out and hear singing birds, they're actually signaling their territoriality. And these vocalizations are credible. If you hear a wolf howl, there is a wolf there. If you hear a lion roar, there is a lion there. If you hear a howler or monkey howling, there is an individual there. So it's really a credible signal of prior residence. And there's quite a bit of evidence that these are very effective at repelling intruders to the territory. So what would this explain that sexual selection would not explain? Well, it explains signaling by both sexes to both sexes. We see females engaging in territorial signaling. We see males engaging in territorial signaling in many species. And the intruders can be males or females as well. It also is a non-mating kind of political context. Territorial contests are quote-unquote political. And it involves non-sexual emotions like fear, for example, and anger. Now, when we look at primates, many primates, male primates, give these loud calls, and they're probably territorial advertisements. And if we look at, this is a big phylogenetic tree of primates, and the black lines here are all the primates species in which males give loud calls. And what you can see is the vast majority of primate species, the males do give loud calls. These are territorial advertisements. It's probably the ancestral state. And then here are the hominoids, the apes, us, and you can see all of the apes also give these loud calls. Now, social carnivores also give territorial signals, and this is important because humans evolved as social hunters. So lion roars, hyena whoops, wolf howls, African dog howls. So what we see is as primates, we would very likely, as our ancestral humans, would have given a loud territorial signal because most primates do that. But as a social carnivore or a social hunter, humans would have also likely have evolved to give these loud territorial signals because most social hunters, most social carnivores do. Okay, so this would explain why ancestral humans would have given loud vocal signals, or maybe even instrumental signals, to signal that they own territory, that they're willing to defend that territory, and to repel intruders in that territory. But that doesn't explain group performances and high levels of synchrony, nor does it explain the high levels of variation we see in music. So how can we explain those? Well, what we see in many social species is coordinated territorial signals. And that, again, is a highly credible signal. So if you hear 2 wolf howls, there are 2 wolves there. If you hear, 4 coyotes yipping, there are 4 coyotes there. If you hear 2 birds duetting, there are 2 birds there. So it's these coordinated vocalizations credibly signal that multiple individuals are cooperating to defend that territory. And again, these are very widespread in nature. We see duetting in birds. This is likely signaling the cooperative defense of territory. We see it in social carnivores, coyote packs. Where I live, we hear these all the time. Wolf howls, lion roars, all of these social species that defend territory in groups give coordinated, loud vocal signals. And we also see it in apes. And it's especially interesting that some of our relatively close relatives, the gibbons, these are the lesser apes, give these highly coordinated territorial signals called duets. And we also see chimpanzees giving highly coordinated vocal signals, likely that partially function at least as territorial signals. So what I'm proposing is that territorial signals are proto-music. They're loud, they're auditory, they involve individual and group behavior, they're coordinated, the signal senders include both sexes, the audience includes both sexes in all age categories, and they involve a variety of emotions like anger and fear, and they involve quality judgments, how many people are sending, or how many individuals are sending the signal. So, could human music and dance be a territorial defense system? Well, we see war dances and war songs in many, many groups. Here are the Maori giving one of their famed war dances here. And actually, interestingly, the US military spends a huge amount of money on military bands. It's kind of interesting. Okay, what's the big fly in the ointment with this idea that human music is a coordinated territorial signal? Well, people like music from other groups. If it was just a territorial signal, whenever we hear a foreign group performing music, we should get afraid and leave. We don't. We actually are attracted. We pay good money to go listen to the orchestras and bands of other groups in other countries. So that's one thing that we need to deal with, and very important. And music is often highly synchronized in a way that coyote yips and wolf howls and lion roars are not. So what explains that? And finally, there's lots of variation in music, things that we don't hear huge amounts of variation in wolf howls, for example. And what I'm going to argue is that music has additional features because human territorial defense is more complex than we see in these other social species. So when we look at primates, conflicts between groups are common. A standard coordinated vocalization would work well there as a territorial signal. But cooperation between groups in non-human primates is essentially unknown, with one exception, the Hamadryas baboons. But other than that, primates groups don't cooperate at the group level. But humans do. We defend territory by forming alliances with other groups. Groups cooperate at the group level. This is a key part of our territorial defense system, alliances by marriage, alliances by descent. And so we face the problem that if we're going to form alliances to defend territory, which allies do we pick? Who would be the best allies? So we are arguing that a high-quality coordinated signal is a signal of coalition quality, that human groups are not only having to make decisions about what the strongest group is that they might be in conflict with, but what is the highest quality group that they have to form an alliance with? Should we form an alliance with these guys, or should we form an alliance with these guys? We've got to choose one or the other. And so what we're arguing is music and dance are basically coalition quality signals. Both groups are trying to impress potential allies, and they're doing this. So we're arguing that music is a credible signal of coalition quality. And it's credible because to achieve these high levels of synchronization takes lots of practice, and that indicates a willingness and ability to work together, to really give an impressive performance of music. People have to have cooperated for long periods of time practicing that music. So human groups were not just trying to scare each other, but we were trying to impress each other with good music and other forms of cultural production so as to attract high-quality allies. And this is a very common feature in the ethnographic record. We see what's called feasting. These are where alliances are forged and maintained. And music and dance are ubiquitous features of feasts. And visits between groups. So for example, the Copper Eskimo are constantly paying visits to other communities, and every visit of importance is marked by a dance in which leading members of both sides take part, just for example, one ethnographic example here. And there are, of course, music and dance are very common during group conflicts as well, war songs and war dances. So we're arguing that performances like this really signal that these guys have worked together and cooperated together for a very, very long time to achieve this incredible level of synchronization here. And that would impress people that these guys are a high-quality coalition. And we see here another example, high levels of synchronization, local group from my area, high levels of synchronization. And to achieve that, it takes lots of practice, lots of cooperation. I'm going to just skip over some of this stuff. How much time do I have left here, would you say? 5 minutes? Okay. One more aspect of the hypothesis is, why is music so involved with emotions? Music can reliably communicate recognizable emotions to listeners, even those listening to music from an unfamiliar tonal system. And if we think about emotions like anger, we signal our emotions. So we're not just internally angry, but we give cues to potential adversaries or allies that we are angry, that we are sad, that we are happy, and that we are surprised. And the evolutionary account of these emotional states is that they serve to organize and orchestrate strategic responses at the individual level. Well, if music is a coalitional signaling system, if the whole group is angry or the whole group is happy, there would be needs for that whole group to signal anger. For example, anger at an enemy intruder. So not just that the individuals are angry, but the whole group is angry. And so what we argue here is that the emotional component of music comes from the need of an entire group, a coalition, to signal their joint state of either anger or happiness, anger at an adversary, happiness at a high-quality ally, for example. And we see ethnographic evidence for this as well, where an emotion may be either individual or collective. It's the collective aspect that finds expression in song. Okay, so how can we unify the coalitional signaling hypothesis with the sexual selection hypothesis? Well, alliances between coalitions are often formed by marriage. And so evaluating allies also entails evaluating mates. And coalition quality is a component of mate value. The value of a particular person as a mate will also include how many friends they have, how strong is their coalition, will their coalition defend me, will they be able to defend me? So we did have a little, so basically because alliances are often solidified by marriage, groups want to display both their coalition quality and the quality of their potential mates that they might be marrying off to their allies. You guys marry my daughters, my sons marry your daughters, and now we have an alliance. So in summary, loud auditory territorial signals are ubiquitous in primates and very common in social carnivores. Humans are primates, and our ancestors were social hunters. Music and dance are universal features of feasts, events that are critical to political alliances between groups. So could music and dance constitute a system to signal coalition quality and coalitional mood? Thank you very much. Questions? Or we're going to save the questions to the end, I think that's right.
So next speaker is Juan David Leongomez from El Bosque University in Bogota, Colombia. And he will talk about musicality in human vocal communication.
Let's see if I can. All right, thank you for this invitation. So just to finish this, this symposium, I will talk a little bit about musicality, kind of in the wider field of human vocal communication. I want to also thank Ed and Marco for their wonderful presentations, which actually are, in a way, similar, obviously, to mine, but there are also some key differences that I will try to explain. All right. First, basically, what I will do is try to present a model for the evolution of musicality that I've been thinking about for many, many years. But first, I will try to do a little kind of introduction about the problems of studying the evolution of music and musicality, and a few of the theories. They both have presented quite a few of the main theories or main hypotheses, which will help me help me save some time, but I will try to present something. So I want to highlight that obviously it's interesting that we are the only animals that actually talk or that have proper language. But as Marco also suggested, we are also the only animals that have proper music and proper musicality. There are more than 4,000 singing species that have songs, or what we call songs, but we are the only ones that go to that level, right? And so I think the question can also be asked in that sense. Why are we the only properly musical animals, right? That requires an answer. Of course, studying the origins of music is complicated because we lack kind of intermediate stages that help us understand the evolution. So we don't have other kind of extant hominid species with different degrees of complexity in their vocal behaviors or the musicality or even language or something like that. Of course, musicality, music, and in general, acoustic communication does not leave a fossil record. I mean, we can infer some things from fossils. We can sometimes, from archaeological findings like a very old musical instrument, infer something, but we don't know exactly. That doesn't tell us exactly when it happened. For example, the oldest instrument we find, of course, has to be predated by musicality by a long time, right? So we don't know much about it. Well, on top of that, there is a problem that I find, and it's some kind of division that happens between the humanities and the sciences when we look at music. In the humanities, and I will illustrate this with musicology, the common view, or the most common view, is that there are no universals in music. I'm not saying the most common, but it's a common view amongst the musicologists. There are no universals in different music. So this is, of course, based on the huge cultural diversity that exists in music. And they treat even music not as one concept, but they talk sometimes about musics, like something that cannot be thought as one phenomenon. That would imply that different musical manifestations, cultural manifestations, lack commonalities. And they can only be understood within their specific social context. So you cannot compare one to another, basically. Of course, I have to clarify that this is not the unique view or the only view that exists in the humanities. John Black, an important musicologist, actually said that every society has some cultural manifestation that can be recognized as music, suggesting that there is some, that there are some universal aspects to music. In sciences like biology, psychology, and anthropology that have looked at music, normally people tend to look at common features, which is quite the opposite way of looking at things. Instead of trying to separate and look everything as a different, as an individual manifestation that cannot be compared, they tend to try to look at the whole of musicality, of music, sorry, and try to understand what is common, right? This has created kind of a division because, of course, on the one hand, some people are looking at the, or specifically focusing on the cultural differences, and on the other hand, people are trying, or scientists are trying to look at music as a universal human phenomenon. This creates a problem, that a division that often prevents communication, and that is problematic because we need both views to really understand the phenomenon. Okay, so to summarize this, in the most extreme way, there are two views about the origins of music. One is that it's purely a cultural construction. Another one says that it has a biological basis. If we go for the cultural constructions, we can think, for example, that there is this concept of musics with no universals is the right one, that there are no common principles that allow comparisons or generalizations to be made. So in that sense, probably the scientific study of music doesn't make sense, right? Wouldn't make sense. On the other hand, if we think about music having a biological basis, we have to first consider the problem that the immense cultural variability and the diversity of functions of music between cultures imposes. So this will make it hard to define what music is for, how it arouses, and yeah, all these kinds of things that seems to be very specific to different cultures in many ways. Although, as they both had mentioned, and I will mention later as well, there are some common functions of music as well. We, however, know that today our brain, our psychology, or physiology make us capable of doing music, understanding music, and playing music, and dancing, and all these things. So in a way, I think still today, even though tracking the past is complicated, we have some cues that we can explore to try to understand how music arose. And another thing, even if music, if we don't want to get into the problem of whether music is universal or not, musicality is universal, right? And I will talk about that more in a little bit. So how to address music from a scientific perspective? I think one problem is precisely that. Scientists have often tried to focus a lot on music, but music is a behavioral manifestation. We should, or it could be more pertinent to focus more on musicality rather than music, on the capacity, because that is more obviously universal. And however, this capacity is likely consisting of multiple mechanisms, both for production and perception of music. I will talk about that more later again. And it's important to consider that because there are different mechanisms that come together in musicality, these mechanisms might have evolved independently. So finding one single answer to the origin of music might be impossible, right? Also, and this is important as well, most theories point to a kind of a connection, an evolutionary connection between music and language, which is an interesting thing. But this shows that, or suggests, at least to me, that the domain of musicality might not be limited to music. That the domain of musicality might have also a role in other domains, such as infant-directed speech. I will speak a little bit about infant-directed speech in a second, and potentially also adult-directed speech. I will use that IDS for infant-directed speech frequently, by the way. What is infant-directed speech? So basically the way that we talk to babies, especially pre-linguistic babies, before they learn how to speak, we communicate with them, if they don't understand our words, by exaggerating the way we speak. So this is from a nice paper from Patricia Kuhl, and this is one woman. This is basically how she speaks to an adult, and this is the same woman speaking to a baby. And you can see how exaggerated the contour is. It's super exaggerated. Hello, and things like that, right? Which is interesting. And also, this kind of exaggerated pitch variability, of course, depends on the perception of differences of pitch. And that will be, of course, necessary for perceiving something like a melody at some point, right? So it might be connected at some point. Okay. However, apart from all of this, we do have quite a lot of evidence for music universals, and that is interesting. I will not go into the detail for time reasons, but for example, Fritz and colleagues show that emotions, or certain emotions, can be recognized cross-culturally in music, that of course the importance of consonances and dissonances seems to be universal. Sandra Trihop has shown that there is universality in the perception of these melodic contours. For example, that there is a universal music genre for infants or towards babies. And Samuel Mayer more recently has shown very interesting things. For example, that musical forms across the world can be described by two components, which are pitch and rhythm, primarily. That musical behaviors, on the other hand, can be described by three components: arousal, religiosity, and formality. And that there is a robust cross-cultural association between these forms and functions in vocal music, and that these functions, like for example, if music is towards baby or things like that, can be detected by listeners around the world, which is very interesting. Now, this music-language relationship. Of course, we have evidence both of shared network resources, but also of distinct neural resources for the processing of music and language. For example, in terms of syntactic processing, we know that children who have SLI, who have problems processing syntactic information in language, also tend to have problems processing the syntax of music. Music also requires some forms of syntax. There's evidence suggesting that the brain will treat musical and linguistic information as the same thing on the early stages of development. And interestingly, music therapy has been successfully used for speech rehabilitation, and there are many examples of this. So, but there is also examples of, or evidence of distinct neural resources. So, for example, there is additional activation of neural areas or brain regions when we sing compared to when we speak. In some amnesias, people can lose the ability to do music but still retain the ability to speak. In some aphasias, the opposite happens. People might lose the ability to speak while retaining the ability to singing or playing music. So is musicality an adaptation? Patel has an interesting argument, and he says, even if we have all this evidence for universality and specialization of processing of musical information, this could be explained without evolutionary adaptation. And he gives examples of reading and writing, which are cultural inventions that can be affected by genetic disorders, for example, that can be hereditary, and is associated with functional specialization of regions of the brain. However, and again, I think we should focus on musicality because unlike reading, writing, or music, musicality is not a behavior, right? It's just a capacity and doesn't seem to be learned. Apparently, nobody has to teach you how to process music. Musicality can be present from birth, potentially. There is evidence that suggests that, or even earlier, before birth. And so I would argue that the question of whether music is an adaptation could be a dead end, and I agree with Tekim Sefic on that point, but the origin of musicality is not a dead end of whether musicality is an adaptation. So I will probably run through these because I don't have much time. But I wanted to show a couple of ideas of the evolution of music, of the evolutionary study of music, how, what is the state right now. So, of course, as Marco suggested, Darwin was the first one to point out that music doesn't seem to have an obvious role of biological relevance, which makes it complicated. Musicality is likely to consist of relatively independent components. We know that pitch and rhythm, for example, seem to be independent. People might lose the rhythm capacity while maintaining the pitch processing capacity, or vice versa. So there is some independence in that. And again, so it's unlikely that we have one single answer for the evolution of music. Probably musicality, just to run a little bit, will involve both adaptations and acceptations. We have different components with probably or likely different evolutionary paths that can involve different things. So it's not going to be easy to find an answer. And for a complete picture of the evolution of music, we should consider both the biological and cultural aspects. And these two, these biological and cultural aspects, might be very interconnected when we talk about musical manifestations and the perception of those musical manifestations. So this is a very complicated topic in a way. Okay, of course, there are a few critical ideas to understand the evolution of music. First of all, we have this idea of phonical precursors. I think both Ed and Marco did a very nice example. Of course, we have examples of things that we call songs. Thank you. Sadly, the vocalizations that we call songs don't happen usually in closely related species. They tend to be in distant species like whales and birds and things like that. But we have evidence of similarities in some aspects or some of these potential components of musicality. we have elements related to human vocal communication in general. We have, for example, the appearance of semantic-like elements in several species. We have syntax-like elements in other species. And of course, we have things like entrainment. We have this cockatoo here just dancing to whatever. They are able to do that. Chimpanzees, as Marco showed, are also able to or have this ability of entrainment, which is a requirement for human musicality. Now, of course, the most popular theory, or at least the, I don't know if the best, but the most popular is sexual selection. And there is some evidence for that. But music is in no way limited to that, right? Of course, as Ed was showing, music has an important role also on displays of groups, activities, and things like that. Quite a few people have suggested that there is some kind of common ancestor because of that between music and language. That there is a form, an older form of now vanished form of communication called sometimes music-like proto-language or musical proto-language that was neither music nor language but had components of both. Then, for specialization later, kind of both separated. Parent-infant communication is another important theory for musicality and the evolution of complex vocalizations in humans. And I will argue that this is interesting because it has some advantages. First, and there is nice evidence for it. For example, the universality of lullabies, and not only that, but the calming effects it has on infants, or the lullabies can have on infants. They are used universally to calm infants. And we also have the universality of this infant-directed speech, and its characteristics is absolutely universal. So an advantage of this line of thinking, I think, is that it can explain those universal phenomena. Also, compared, for example, to sexual selection, it could explain the very early development of musical abilities and the perception abilities, sorry, the universal existence of these lullabies and IDS, and some people have even suggested that an infant-parent communication theory might also be a precursor of this idea of a musical proto-language. All of these theories, in any case, share a few components, even though they are very different. They invoke the benefits of obtaining some form of social interaction, whether it be made choice or within group social bonding or advertising or parent-infant communication. But again, we have to be aware that different benefits of musicality could have been applied at different times during its evolution. This is a complex phenomenon. So, sorry, I will just, there were some alternative views, but I will just skip this. Go. So, I will talk a little bit about the model that we developed. This was just a recap. Come on. So, talking a little bit about pitch and rhythm processing. We wanted to involve these two separate components in a clear way in our model. First, we know that human neonates can process pitch intervals in a very similar way to adults, or at least some literature suggests that. IDS primarily functions to communicate affective states, which is important, and infants actually prefer kind of speech directed to them that conveys a positive emotion, which is also very interesting. So it seems that they kind of get the emotion that is being transmitted. Rhythm, on the other hand, seems to be of particular importance for synchronization and entrainment, even from early infancy. This is consistent with the hypothesis of Robin Dunbar's vocal grooming hypothesis for the evolution of language and stuff, and also for ideas like music as a credible signal for coalition and intent, as Ed just presented, and he has several papers on that. And of course, it's manifested today in group activities all around the world. So, in short, we believe that pitch processing enables parent-infant bonding and communication through the inferral of emotional states, or that's the primary option, whereas rhythm processing enables a mechanism for social bonding and group identification through synchronized behaviors. Why do we think that IDS might be the primary driver of human musicality, or the original driver at least? First, because the communication between infants and parents is critical for creating a bond and for kind of helping the children survive. If there is not a strong bond, probably the child will die. And also, this social bonding and this social communication between especially the mother and the infant will promote social learning. This is also necessary for language to evolve. This kind of bond, of this, basically, infant-directed speech could work as a developmental tool. So, if this was true, if in fact infant-parent communication promotes survival, the selection could have acted on individual abilities for musicality. We know that musicality is at least partially hereditary, or some aspects of it are at least. What I think is, if more musical adults, then would probably have children with better chances to survive, or they communicate better and maximize the chances of these children to survive, then they will in turn have children that will be better equipped to be better parents, to communicate with their kids, with their children. This is interesting because this will also integrate support for a sexual selection hypothesis in a smaller way, but it will be there. Do we have evidence for this, for some sort of sexual hypothesis within this model? Yeah, it will require sexual selection to have some form of display of musicality during courtship. And there is evidence for this. I have a paper, Kasia Pisansky has another one, that have shown how we increase the variability, what happened in IDS, when we talk to babies, we increase the variability of our speech when we talk to somebody we are attracted to, right? More recently, I showed in a more recent paper that basically what we have here is variability. This is for women, this is for men, this is the variability of their speech, and this is the ratings, the attractiveness ratings they gave to people they were responding to. And as you can see, the variability tracks very well the attractiveness of the people they are talking to, right? This is just the average, the mean pitch, so basically if they are speaking a higher or lower pitch, and there is no clear association there. On the other hand, if we look at social status, we, for example, see that there is no this kind of increase in pitch variability when people are talking to others in terms of being dominant or submissive, or I don't know, or more prestigious or anything like that. So it happens in courtship, which makes a lot of sense, I think. Okay, so we ended up with a complex model. I will not explain it in detail, but we have some cognitive components that include things like rhythm processing and pitch processing that combine probably with other things to create what we call musicality. And we also have things like syntax and semantics, and these things are represented in excess as forces, adaptive forces that kind of force specializations and generate different communicative behaviors. So from ancestral things that just work for group cohesion or have this bond with babies, then we end up with a kind of a proto-musical language where signals of musicality might appear between adults, and then because of specialization in syntax, we end up with a separation between music and language. Recently, two papers, and this is just to end, two papers were published, luckily or sadly, I don't know, just when mine was under review, on behavioral and brain sciences that have two different models for musicality. One by Savage and collaborators, another one by Samuel Mayer, including Ed, and they propose different functions of music. And I have, or the model I propose, shares some ideas with those models, but also has some key differences. So the model of Savage suggests that the function of music is social bonding, whereas this model suggests that it's a credible signal for coalition intent and potentially parental attentiveness. This model that I propose shares some ideas, for example, the importance of social bonding with this one. And with this model, it agrees that the sexual selection is unlikely to be the primary driver of human musicality, that melody evolved in the context of parent-offspring communication, and then rhythm evolved in the context of group interactions. However, there are also some key differences. On the one hand, with this one, we think that musicality cannot be, it has to be placed in a field that is wider than just music. Maybe the name musicality is not the best one for what we're thinking about. I mean, we tend to link it specifically to music, but maybe it's not specifically or only linked to music. Also, I think we need to differentiate the evolution of pitch and rhythm abilities, and this model is not doing that. With this model, we believe that cues of the ability, the music capacity, the musicality, might exist in species that have alloparentic and or biparental care, and be preferred in potential long-term partners. That will also explain, for example, the universality or potential universality of things like love songs and serenading and things like that. We make a bunch of predictions from this model. I will just highlight 3. Basically, we expect rhythm to evolve only in species that have some need for coordination. We expect pitch processing to evolve only in species with some kind of altriciality and long-term parenting. And musicality only in species that have these 2. There are a lot of other predictions, some very specific. So a few ideas just to round this up. Models, I think, should focus on musicality rather than music. The modules for musicality, like pitch and rhythm, may have different evolutionary histories, and that is important. Musicality may predate music, and musicality today could be working in other domains beyond music. I want to lastly thank my 2 co-authors, which are Jan Havlicek and Craig Roberts. Jan from from Charles University in Prague, Craig Roberts from Stirling in the UK. This whole model in detail is published in Philosophical Transactions. And a little bit of self-promotion. This is part of a 2-part theme issue on voice modulation that I edited alongside a group of great scientists, including the fantastic Jarka, who is over there. She was one of the editors as well. And yes, thank you very much.
Well, I think now we have time for questions. I believe the speakers will join the table.
Other questions? Oh.
Hi. Well, thank you for your wonderful presentations. I have a few ideas that I wonder if you'd be interested in examining, especially with regard to your argument about melody having to do with parent-child relationships, while rhythm has to do with, creating coordination among soldiers or whatever. I think both in terms of cross-species studies, I'm looking for correlations here, and cross-cultural studies. I think if you look at societies, different societies, ones that have practiced more warfare, which demand more coordination among the soldiers. I recently wrote a story about the Spartans. Spartans were so coordinated that the rest of the Greeks considered their war maneuvers to be dances. And they were the most musical of all the Greeks, according to this, but it's mostly because of the rhythm. And I'm wondering if that might get a good cross-cultural correlation there. I kind of I come from cultural anthropology, so I'm always interested in cross-cultural correlations here. Nobody mentioned Lomax as classic studies of cross-cultural correlations of aspects of music and various cultural traits. That's one suggestion I have. You want to think of the cross-cultural correlations and cross-species correlations. You suggested them there. I wonder if anybody studied them. Is there anything like the ethnographic atlas for primates? Does anybody know of any database that could be used for analysis of that? Existe uma base de dados sobre primatas ou diferentes espécies sobre esses assuntos que poderia ser analisado ou teria que passar espécie por espécie para examinar essas questões? A nível de cultura é fácil, tem códigos já existentes para isso.
So there's a lot of research on primate vocalizations, and what that research shows, one of the most common types of vocal signals in primates and actually other species are contact calls. So parents, members of the group are often giving vocal contact calls to locate other members of the group, and these are particularly common between parents and offspring, so that offspring can signal their parents and parents can signal their offspring. And when you look at the vocal characteristics of contact calls, they tend to be more melodic than other kinds of calls that primates are giving, such as aggressive territorial signals and things like this. So there does seem to be some association with more melodic signaling in contact calls. And very similar to David, we're proposing that this infant-directed song basically is evolving from contact calls in primates for, and the only slight difference with our hypothesis with David's here is that we propose that infant-directed song is a credible signal of attention. And the reason we think that's necessary is if you look at chimpanzees, chimpanzee moms are raising one infant at a time, and then that infant basically matures and they go, it's a 4-year process, and then they go to the next infant. In humans, we have a much shorter birth interval, and so parents and alloparents, as David mentioned, are dealing with multiple young offspring. And so an infant can't assume that the parent is just paying attention to it. It could easily be paying attention to other young kids. So we need a credible signaling system for parents. So we basically propose infants have this very aversive cry, I need attention, and then parents respond with a much more soothing, melodic contact call here, I'm paying attention to you, I'm not paying attention to your brothers and sisters. So there is primate evidence for that. I don't know of cross-cultural evidence.
Across species, if you could find a correlation, I mean, a real correlation, with lots of cases where you can say these primates have more need of greater protection by parents, and this is more related to pitch variation or whatever. I'm just looking for a real correlation. If that's possible, if there's enough data on the primate species. No, not enough.
Yeah, I don't know.
The other question,
Well, I just wanted to add something that I don't think there is data enough for a correlation, don't know that I have seen. But there are, I think that's part of the problem of these theories, and we are basing the theories a lot of, on individual points, data points, results that happen here and there from different areas. And that is, it's complicated to put everything together. So it's easy to find evidence that supports pretty much every or any hypothesis. Of course, we also have evidence that contradicts pretty much every hypothesis, so that's a complicated
So you need
thing.
statistics here, yeah.
One thing I wanted to mention, a small one that I love, is a few studies that have shown that in marmosets, there is some form of babbling of babies when they are learning to their vocalization.
That's the other thing I want to comment on mother-infant relationship. It may not be just, it might be more like getting your heartbeats in tune with each other. I mean, people tend to beat together if they're together, and that can be very soothing, the fact that you adopt the heartbeat of someone who's calmer. That's another, Oh, I also, a research paper I once saw that was just kind of funny, also worthy of an Ig Nobel, talvez. Maybe it did win an Ig Nobel. It's the idea that babies cry as soon as neonates, when they cry, reflect the accent of their country. So French babies tend to cry up. The German babies tend to go. And so there's those. They don't. Not enough cases to be correlations, but there's maybe a relationship there.
Any more questions? Justin? So I've been trying to think about some universal property that cuts through, or some universal mechanism that cuts through each of the models that you've presented here. And I keep thinking about how music creates sustained attention capture. So that is, when you hear music, when I play music, one of the things that I enjoy about it is if it's really good music, I can't help but pay attention to it, right? It has these qualities where it just rips your attention away. And so I wonder to what degree that might be almost like a primordial or proto form of musicality where you're just, I mean, if you look at the evolution of the ability to capture attention through rhythm, through all these aspects of music, that then feeds into and then could become a mechanism of attracting mates or defending territory or, you know, raising infants and capturing their attention. So I'm wondering if you think that fits into all of this in some way.
Yeah, it's a very nice suggestion. Yes, I think so. I think that for all those hypotheses to work, music has to have this like underlying property that capture our attention, right? And it's very interesting because music has a lot of repetition, right? And we don't accept too much repetition in speech, right? When you say the same words, gets boring. But in music, the fact's not like that. There are many parts that repeat, and we keep listening, and we are almost in flow, right? Our attention is completely focused. So I think it's a nice idea.
And it kind of makes me think about the difference between, you know, if you hear a howler monkey, they make one noise and they're getting attention, but music's really about getting attention and then keeping it, and almost taking someone on a journey or a story, right? That seems like a major difference.
Yeah, I think what I would add is, at least under our hypotheses, that music is a credible signal, so it's providing critical information, and to evaluate that information, especially in terms of coalition quality, you have to listen for long enough to get to be able to evaluate the level of synchronization and the quality of the music. So for that signal to really function properly and provide the information to the receivers, it's going to require sustained attention on the part of the receiver. What we're arguing is the advantage of music is if you had to assess coalition quality by actually watching the coalition in action, you might be there for days or weeks or months to see, do these guys really work together? Do they hunt well together? Do they fend together? To actually collect that information by watching the group's actual behavior, cooperative behavior, could take a very, very, very long time. And so what we're arguing is that music is a very condensed, credible signal that in a relatively short amount of time, of minutes or maybe an hour, you can really get a very fine-tuned sense of how cooperative that group has been in the past, which is a good predictor of how likely it will be cooperative in the future. So that would be my take on your question.
Thank you.
Anybody else? Okay, I'm gonna ask a simple question. All right. No, mine's really easy. You can talk. Please.
Sorry. I was just thinking of the three main reasons for music evolution, which you basically talked about, which is war coordination, sexual selection, both in terms of attracting mates and scaring away rivals, and lullabies, which I think those three I've always considered pretty important. And I wondered if the types of music that we hear may not have some correlation with these three characteristics. In terms of national hymns, for example, which are usually about war, you know, Desafia nosso peito à própria morte, or Au Canada, we stand on guard for thee, allons enfants de la patrie. They're all about going to war, encouraging people to get together and go to war. And the rhythms tend to be pretty marked, and the melodies usually, mostly, are pretty simple. Brazil isn't simple, but other nations have very simple tunes. And they're much easier to coordinate and get strong, regular beats, regular, constant. You can maintain the timing very well. And I'm wondering if there may not be types of correlations between, I'm thinking of cross-culture correlations, or maybe even within a culture, checking these three different types of music and finding correlations between marked rhythms versus sexual selection. I mean, swing is hard to coordinate. That doesn't work for warring parties, swing music. It's, the syncopes just don't work. You can't do it that easily. Even Brazilian music, which is extremely syncopated, but in a different, but not in terms of swing, when people start singing it, you'll often see that the non-professionals don't quite get the syncopes right, because I go crazy trying to get them right. And I noticed that most Brazilians, in fact, don't get them right. And so I'm wondering how, suggesting another type of correlation there among the types of music in different societies and
I was thinking about some studies, mother-child interaction, and how they coordinate their talk, you know, and it's called proto-conversation, yeah, and they use especially intonation. And it's so nice, you know, I even did a study like this on twins and the mother, just analyzing how they imitate, you know, the intonation one another and can create a proto-conversation only using this index now of intonation. So I think this illustrates a little bit of what you said, you know, about this parenting. You know, it really, I think, has an important effect, you know, on parenting, this synchronization on the rhythm and the melody and all those aspects, you know, proto-aspects of musicality. You know?
Sorry, I want to add something little, that this turn-taking that happens between mothers and babies or parents and babies also can be some kind of important for language acquisition and the turn-taking of language. So it is important, I guess, yeah.
These are studies on language acquisition.
Yeah.
They show all this synchronization on this. These are studies, this field, language acquisition, they do lots of studies. There have been studies like this like for 40 years right now. Very descriptive and very intense observation of communication, mother-child, early communication, and all that communication from the first weeks of life. It's emotional and rhythm and melody, intonation. It's all based on this proto-musicality that you mentioned. No? Very interesting. No?
So I think mine's the last question. It's an easy one after all these great questions. I just wanted to ask you, all the speakers, if you play any instruments.
Yes.
Which one?
No, I play the flute and the nose flute and the guitar and a little bit of bass. Yes, and the body, of course.
I played trumpet in high school, but not since.
I technically am a musician. I graduated as a musician, but I stopped playing. I formally am a professional double bassist, and I play, or used to play piano, but I haven't played anything for more than 12 years because at some point I discovered that I prefer to look at music like this from a safe distance and not touch it that much because it was destroying my life. So I love music, but not living from music.
It was a nice ending. So thank you very much for wonderful symposium.